Well, I thought that's just not good enough. You know, if you're a data grid, you need to run Doom. And so you can click.
What?
The whole thing is being rendered. Every pixel's its own cell. It's totally playable. Yeah.
Oh my goodness.
Wow, that's a great demo of the grid's performance. This was a pretty illuminating conversation about a canvas-based data grid that can handle 100 million rows at 120 frames per second. And if you're not sure whether or not that's a lot, let's just say it's like 100 to 1,000 times more what other grids can handle. It even runs Doom. And it does all this while maintaining a great accessibility story, having a flexible styling engine, supporting things like server-side rendering, and of course having great TypeScript types, and a lot more. So Jason, the main author of Glide Data Grid, has had a lot of experience in this domain, and so we went off into other topics and talked about like how to blit together two rectangles without a seam, moving things on a subpixel line, and stuff like that. Ryan, the co-host, has also had a lot of experience in this grid domain in the past, and even with that deep experience, Ryan and I were both completely wrong about some of the things we thought about Canvas. So we learned a lot in this one, and we hope you can learn something too. Let us know what you think below. Welcome everyone. We have Jason here from Glide to talk about Glide Data Grid. Anybody who's interested in high-level programming, JavaScript, many other languages will probably have come to a need at some point in their career to put data into a table. And there's lots of ways to do that simply, and there are a few ways to do that complexly, kind of like Excel. And there are many options in the market, but Glide Data Grid really caught my attention because it's got a lot of really cool features, and there's a lot of interesting stuff here. So Jason, welcome. Actually, Ryan, would you mind introducing yourself first, and then we'll go to Jason and we can jump right in.
Yeah, I'm Ryan. I'm a front-end developer. Been doing React for a while, TypeScript as well. Looking forward to kind of getting an overview of Glide and see some what's going on under the hood here.
Don't forget to mention Griddle.
Oh, yeah. Early in my React days, a project needed a data grid and there weren't really any good options back then. I started working on a project that maintained for a couple of years called Griddle. Don't really actively develop that anymore. And I think it's on like React version when they were still in the point releases. So it's not maintained, but definitely can empathize with the need for building data grids. So excited to see this one.
Awesome. Jason, how about you?
So I am Jason, as you know. I'm one of the founders at a company called Glide. We make a tool for creating business software. So if you need to, make a way to track inventory or, manage HR complaints or whatever you want to make, we have a no-code platform for building software. And we took a data first approach to things where we wanted to have you bring your data to us and we help you put together screens and workflows and that kind of thing. And so you might imagine very naturally, you very quickly begin to need a data grid style thing. And then Glide Data Grid becomes born.
The question on my mind, and I bet other people's mind too, is why did it start off with building something from scratch on your own, or did you check out an AG Grid or some other table software?
I wish I could tell you that I am such a prescient software developer that I need to build this from scratch myself from the get-go. But no, I did the boring thing of tried everything else first. I started with some of the third-party grids. You mentioned some of them. And, they're nice. They do a lot of things for you, but they require a lot of configuration. And if you really want them to look the exact way that your designers want things to look, and you want them to behave the exact way your designers want them to behave, you're in for a lot of pain. You have to take, kind of how they work with them. And that was just not something that we wanted to compromise on at the time. So we moved into doing something with React Virtualized, which I'm sure you at least have heard of. It's a giant project. And, we did a version with that. And then we realized, our customers have hundreds of columns. So now we need to, virtualize not just vertically, but horizontally. So we have this 2-tier system going on, and making that work. And then you start adding things like, sticky headers and sticky columns, and things really quickly start to degrade, and you start to get into this really rough situation. And at a certain point, I just decided, this whole DOM thing probably isn't that hard. I don't know what all these browser developers are complaining about. I'll just remake a DOM in a canvas. And And that was kind of the beginning of this. Here we are like 5 years later, and it actually works pretty darn well.
Wow. That's an exciting story because many people have been at the beginning of that story, but it's difficult to get a project over the finish line to actually have something that is working. So you're deploying this to customers and this is used in production?
Yeah. So this has been in production now for probably 4 years. And every year it's just getting better and more features faster. The first iterations were many times slower than this, and they were still faster than anything else we could test. This is now the fastest version of it yet, and with more features to boot.
I'm curious to know more about that. Okay, so I want to know how you even measure the speed and all that. But just before we jump in, give us a kind of quick overview. Give us a tour of what it's all about, how it looks.
Sure. So Glide Data Grid is primarily focused on displaying large amounts of data. And so what we have here is kind of this grid, and it's organized into your standard like columns and groups of columns and things like that. And you can click around, you can make your selections. You have the ability to say like, I want to pattern this down 3. So you can just like drag down like that and it'll kind of do the right things. And what you have to remember when you're seeing this is it's really a front end to your data. So you have to provide the data source. It tells you, hey, the user wants to perform this operation, but it's up to you to update that data source to actually reflect that operation. In a lot of ways, it's like interacting with an input element in React, right? Like you say what the value is and it tells you when it wants to change the value, but it's up to you to actually update that state. The data grid works on that exact same concept. It supports scrolling. It supports these like frozen columns. It supports so many things nowadays. In fact, there's a storybook now that is publicly available that just contains pretty much everything you might want to like look at with it. So,
Yeah, I saw spark lines in there and pictures and all kinds of things.
You got pictures, you got spark lines, you want to render Markdown in a cell, you can do that. Basically, what we tell people to do, because it's me writing this thing, it's me doing the documentation. Like, if you want to know if it does something, the best thing to do is go look at the storybook and see if that storybook supports it.
Nice. Do you find that, I know you said it's you kind of doing a lot of this. Do you find that other people are making feature requests, or is it mostly driven from like what you need for what you're doing day in and day out?
So for the first 3 years, it was basically just me hoping somebody cared. And at some point I decided to take the open source nature of this more seriously. So I made, a website for it. And I started trying to make it so it was attractive to other people coming and looking at it. I posted it on Reddit a little more frequently. I started talking about it in different Discords and whatever. And now I do have people that are not only coming and asking for features and developing it and using it externally, but I'm sorry, I already said this, but they're developing it also. So they are, making contributions. I have another maintainer on the project who's not an employee of Glide now. And so that's been really great to watch it kind of like grow into a real open source project. In my background, I've done a lot of open source development. I worked for Canonical back in the day. I worked on a thing called GNOME Do and Docky, which were popular back in their time. And, having the ability to do open source again has been great for me. I was trying to make this more attractive to people. So I've spent a lot of time trying to like find different ways to make, different features in here. So there's like a lot of little Easter eggs that we've kind of hidden throughout the site to try to like get people to talk about it.
All right. What's your favorite one?
Oh, my favorite one. I'm so glad you asked because I was intentionally teeing you up to ask.
All right.
So there's
bait taken.
There's this thing here that if you hover, it does this neat effect. And I was thinking to myself, if you're a data grid, you've occasionally seen like people use Excel to make, little paintings. Well, I thought that's just not good enough. If you're a data grid, you need to run Doom. And so you can click.
What?
The whole thing is being rendered. Every pixel's its own cell. It's totally playable. Yeah.
Oh my goodness.
Wow, that's a great demo of the grid's performance.
The first day I built this, I beat Doom because, you have to, right?
Of course. Yeah. I mean, you're on the clock, right? So, I mean, you gotta work. That's when the task is making Doom. That's incredible. Wow. And that really shows off the render performance.
Yeah, so there are 64,000 cells being rendered here, and like trying to update that in real time with DOM would be basically impossible. Like the equivalent of doing this would be to have 64,000 DOM nodes, one for each pixel, and then you're constantly trying to update them to actually show the rendered output of Doom. Obviously, I'm going to die here, so we'll just click away.
Well, I think you've got like you set the new bar for what a data grid needs to do. Like if it can't run Doom.
I agree. I've been challenging the other grids to do this.
That's going to be a tough challenge to meet, tough bar to meet, I think.
Yeah.
And so, all right, some questions on that. So it's like I imagine there's like some WebAssembly step in the background that's actually passing the pixels.
Yeah. So obviously the data grid is not a computation engine, so you can't like run the Doom code base on it. So there's a WASM version of Doom that's just outputting all the pixels. And then the grid is picking up those pixels and converting them into cells and then just rendering that many cells. And each of them are 5 pixels by 5 pixels.
Wow. That's incredible. I mean,
that is really cool.
Did you think it was going to work when you first tried that? Or what was it? What was the experience like? Like put me in the room when you first got it working. Did it need some kind of tweaking or did it just kind of work?
I wish I could tell you it just worked. It worked at about 5 frames per second initially. And so what I did was just kind of hook it in and said, okay, what's going on here? It turned out that all I had to do really was do some minor tweaks in some algorithms that were just not really scaling well to 64,000 pixels. Or sorry, 64,000 cells. They were just doing some things that are fine when you have this many cells. They were like n squared basically in performance, but when you started having 64,000 of them, things got really bad. And then the only other thing I really had to adjust was removing some extraneous drawing commands that weren't needed for damage updates. So what I call a damage update is when you edit a part of the grid, it didn't redraw all of this. It only redrew the cells that changed. And so the same thing is happening with Doom. Rather than redrawing every single pixel every frame, it only redraws the pixels that change. And that's how you get the other half of the performance needed. I mean, it's like the least efficient mechanism possible to render Doom, but it works.
Wow. And do you think this would be possible with, so you're really relying on Canvas under the hood, right? I mean, is that the kind of special sauce here for the grid in general?
Yeah, so that is the special sauce for the grid, because if I turn on like the huge rows mode here and I scroll, this is scrolling at, my monitor is 120 hertz. It'll do the full 120 hertz, no problem. And it just scrolled through, 100,000 rows, and it can easily handle millions and millions of rows. But there's no dropped frames. There's no, like, other than the images loading, because that's a web request, like you'd never see it render a blank grid with no content in it. It can totally keep up with everything you're doing. And there's just no way to replace DOM nodes that fast and have it keep up. It just will slow down.
Yeah, that's incredible. I'm curious, how are you measuring this performance? Just like using the built-in like dev tools, or?
By and large, yeah. I mean, it's little more than, crack open the dev tools, record a performance profile, and then just zoom in and see what's taking time and repeat that process a couple thousand times. And eventually you end up with something that's crazy fast. Very rarely have I found big wins. It's always been little wins. And you just add them up over time. The only really big win that we ever found, and like, this is something I went into this knowing to do, was when you scroll, like say we have this region here. If you just want to think about that, when I scroll this, let me turn off the large rows so my scroll bar is a reasonable size. So like if we think about this region here, as I'm scrolling, it's not changing really. It's just moving. So what we do is every frame we compute where things were and where they moved. And then rather than redrawing everything there, we're just copying from the buffer and moving it up or down.
So like on the top and bottom of the scroll area, it's kind of rendering like a video game does, kind of like, I think there's a term for this, isn't there? But it's rendering outside of the viewport.
Kind of, yeah. There's double buffering going on for sure. And I'll happily talk about that. That happens particularly on Safari. But if we look at like the layout of this thing, this is the scroll region. And if we look, all it contains is like a bunch of really, really big divs that have nothing in them. And actually what we have is this underlay that's underneath the scroll region. And this is where the canvases are. So the canvases are just looking for scroll events on that scroll region and then drawing what should be displayed based on the scroll region's position. Which means your canvases are always just the size of this, which makes it a heck of a lot easier on your GPU. I
see. I just wanted to mention before you move on, if anybody's watching this wondering what we're talking about, like how this could be so fast. I like to give this example because I always have my water bottle in front of me. It's like if we were measuring the speed it takes for me to fill up my water bottle, you might think like how long it takes for like the first drop of water to touch the bottom to the first drop of water to touch the top. And that's a good way to measure the speed. But if I first have to walk downstairs to my kitchen and like go to my fridge in order to put the bottle in the place where it needs to go to start filling, like the time it takes to do that might be way more than the time it takes to fill the whole bottle. And that's kind of the thing that happens. Like that's why the virtual DOM, I mean, React, it's funny in the early days of React, like the 0.13, days of React, I remember people were like very anxious about having a virtual DOM, but you don't really hear about it anymore. But the reason these kinds of techniques are really important is they cut down that latency. Anytime you update something in the browser, in the DOM, it's like going downstairs. It doesn't matter how fast you make the water bottle at the station. You still have to walk downstairs to do any kind of update. And that's I don't know, I always give that analogy, but this is the time to mention it, I suppose.
Yeah, with the virtual DOM in particular, your bottleneck in something like a data grid almost always is that layer where you're communicating with the browser to actually like perform the mutations to the DOM. And the virtual DOM does a halfway decent job of optimizing a lot of that if you write naive code. Obviously, you want to issue the virtual DOM if you're going to write super optimized code. But the only way to actually get anywhere near this kind of performance right now, especially with these kind of complex cells, where they do way more than just display a single text value, is to issue the DOM altogether.
My perception of writing software that really relies on Canvas is that screen readers have a very hard time. Click events and things like tooltips can be funky. I just have this negative connotation in my mind about anything that uses and heavily relies on Canvas. What do you have to say to that? Am I...
You're way off because...
Good.
Canvas is a superpower for accessibility in a lot of ways. Now, I will admit, the way a lot of people use Canvas is not accessible. They will just create a Canvas element and then do nothing to make accessibility work. What's really great about writing a data grid with Canvas is I was able to create an accessibility tree for users who need it that is just bespoke for them. So instead of having to figure out a way to not only render out the table, but also to make that table accessible to screen readers and maintain the performance, which turns out to be very difficult. In fact, the major grid provider, they have an option to turn on accessibility mode. It's off by default, or at least it was last I looked. And the reason it's off by default is it hurts performance so much. In the case of the data grid, what we do is we just go into this canvas here, and then we just add this subDOM element, which is a child of the canvas. It doesn't render at all. So it doesn't hurt your rendering performance. And then as you're scrolling, we're just updating this DOM. So if we look at the canvas here, so this is the main canvas that's rendering all the cells. It has children, which are a table with a T head and T bodies, and you have all the rows in here. And you'll see that there's nothing interesting about this table. It's just the bare minimum of what you need to get the accessibility tree. And there's no CSS applied to it, no tricky transforms, no reordering crap. It's just exactly what the screen reader needs. And this is what the screen reader ultimately sees. It doesn't see the canvas. And then all we do is we make sure that all of these are properly evented so that if you activate one of them with the screen reader, it activates the correct cell in the grid. And so you end up with this really great accessibility experience. Now, I'm going to admit openly here that I am not an accessibility user, so I do my very best. I test with as many tools as I can, but like I'd love to have additional help from the community on this. But you end up with this capacity to produce a really great experience just because you are not beholden to try to make this table do multiple duties. It doesn't have to both be your rendering output and your accessibility tree. It's just your accessibility tree.
I love that. Yeah, I guess now that you put it that way, it makes a lot of sense. It's extra work in a way. I mean, you had to put this table thing in here, but also it's like very freeing to be able to, like you said, make it look exactly like it should look to optimize for the use case it's intended for. And then it's display none or something. So that how is it that this never shows up on the screen?
So Canvas has this special ability, right? When Canvas has child DOM elements, they just don't render unless the user has disabled Canvas for whatever. But screen readers know to look at these elements.
I think that's a really interesting approach because similarly to you, I had this impression that, if you're using Canvas, you have to do all kinds of gymnastics to make it so people using assistive technologies can be productive on your app. So that's really neat to see.
Yeah, it works out pretty well.
So I'll leave it to you. We could go a couple different directions. I'd love to see the code that does that part that you're showing now, like makes the table rows, and we could talk about performance. I'd love to know how you use browser tools or how you measure performance. Cross-browser support was another one that I thought was interesting to hear about, supporting different use cases or what's different or what kinds of things matter. Where would you like to take us?
So I think cross-browser and performance go hand in hand because most of the performance conversation we can have is going to talk about cross-browser. We can take I can show you very quickly the code that generates that table. It's actually remarkably small for what it is. Okay, so here we are. So this is just the code that creates the accessibility tree. We just make sure that we're generally visible. We have the ability to disable the accessibility tree for performance reasons regarding the need to do benchmarking. So you don't want the accessibility tree rendering when you're trying to benchmark the rendering performance, because what ends up happening is you end up dominating the performance stream. We'll see that later. So this is really just used for that purpose. But all we're going to do is we're basically going to end up getting our columns, figuring out our selections, figuring out what rows and columns are supposed to be visible right now. And then we're just returning out a table. And this is going to look very familiar to anybody who's written a bunch of code. You turn out your table, you get a T head, a row, all the headers, and then you just do all of your rows. And again, there's a lot of computation and math in here to figure out, are you selected? What is your location? Make sure everybody has a unique ID, grab the cell content and then just kind of spit out the table with the right, content inside of it. And away you go. And then here we're just kind of hooking up the click handlers. So the accessibility tools will actually emit these click events. And so you can just respond to them and trigger that right on up to the parent grid and handle it like they had clicked on any random cell. And is this perfect? I've tried my very best to make it as good as possible. There's probably improvements to be made.
It's cool though that an end user of Glide Data Grid doesn't need to think at all about the accessibility story, it seems like, because it's sort of baked in. Is that accurate?
Yeah, by and large, you shouldn't have to think about it. Accessibility to me is something that should be baked into the software. And when you have an accessibility issue with Glide Data Grid, I consider it a high priority bug and something that I work very hard to fix.
Wow, that's a good look for you. That's awesome. I'm very happy to hear that. And it's super cool to see it being taken so seriously. Also, it kind of forces you sometimes to have better designs, I think, when you think about accessibility versus having no constraints and being able to just go wild. Sometimes those accessibility guidelines are just good guidelines in general. You don't have to have low vision for people to benefit from even things like contrast ratios. I know this isn't styling necessarily, but it's good for everyone. So that's awesome. And then about cross-browser, I mean, is there you can make some enemies if you want. Is there a particular browser that is a problem for you, or is that?
Yeah. Its name is Safari. It's my enemy. Safari is. I'm going to say this very, very carefully so as not to overstate the matter. Safari may be the worst browser that I've ever had the displeasure of working with. Yeah.
Okay.
The reality is that Chrome and Firefox, Chrome in particular, has done an amazing job of optimizing their render routines, optimizing every little thing you might need to have done well. They render text fast. It blitz bitmaps fast. It deals with scaling very well. And like, it doesn't have weird behaviors where it's like, oh, you rounded the corner, or like, all of a sudden you're going down a slow path for no reason. With Safari, we regularly encounter this kind of thing. So one thing we do with Chrome is, we have one canvas here, essentially. You can ignore the fact that this other thing is a canvas. Just the headers are their own canvas. Let's ignore that for a moment. You can think of it as just one canvas. And so when you scroll, all we do is we say, from this canvas, draw this rectangle up to this region up here onto the same canvas. And you just, blit onto itself, basically. And if you're really thinking about that carefully, and you think about like the the operations that's happening, it's basically saying, okay, read this pixel, write it there. Read this pixel, write it there. But if I scroll in this direction, right, it's reading this pixel and writing it here, right? I apologize for my bad Latin. I'll just put that over there. What's going to happen is, as I scroll this way, if it reads from the top and writes down to the right destination down here, it's going to end up overwriting data it needs to read later. So it has to know, well, like the blit went this other way, so I'm going to start from the bottom and go up. It has to be intelligent about like how it handles this. And as best I can tell, Chrome handles this incredibly intelligently. It never gets into a situation where it's going, you're going to hit a slow path because you blit in this direction or that direction. The same cannot be said of Safari. As best I can tell, Safari cannot optimally render from a canvas to itself. It almost always hits a slow path. So what we end up having to do is we stand up these like intermediate buffers. We have buffer A and buffer B, and we render to buffer A, and then we blit that to the canvas. And then on the next frame, we blit from buffer A to buffer B, fill in the bits that weren't blitted, and then render that to the canvas. And then we switch back and forth over and over and over and over. And that's how we do it on Safari. And that gets you a gigantic speed up on Safari. It gets you back to pretty much the same performance as you get on Chrome, but you had to work a lot harder to get it.
Can you show us that code?
Yeah, wow.
Yeah. So
is it scary?
Oh yeah. So here's the thing. I've been doing my entire career can almost be summed up as finding different ways to abuse drawing libraries. That's what I did for GNOME Do. That's what I did on Docky. That's what I was doing at Canonical. I was just abusing drawing libraries my whole life. And so you get these really nasty files as a result because you're doing everything in the most performant way possible. And so this is the main draw function right here, draw grid. And it takes the world's most complicated type. Well, not really, but it takes a nasty type. Right? Because it has to do a lot and deal with a lot. And like, I'm not proud of that type, but I am very proud of how fast it performs. So we basically unpack all this.
It doesn't look bad to me.
And, we have our buffers, and we always get our buffers, even though we're not going to use them on Chrome. And what's going to end up happening is we have this thing called the render strategy. And so on Safari, the render strategy will be set to double buffer. And so all we're doing here is we're setting up our buffers. Here you can see we're actually setting up the buffers A and B here. This overlay is the headers. And what we're going to do here is we also set up this main context. This is basically, if main context is set, that means that we need to draw this buffer, the target buffer, back to the main buffer. Whereas like in the event of Chrome, we're always reading and writing from the same buffer, so there's no need for that final step. Then here, this is where we are generating what our target buffer should be. So when we're not double buffering, like I said, we just write directly to the canvas. Otherwise, we look at the last buffer and we're going to ignore the damage case for now. That's this final case here. But when we look at the last buffer and then we swap it. Sorry, this is the damage case. Ignore that. So we swap it. When we're drawing damage, we actually don't swap it. That's for very complicated reasons that we don't need to go into too much, I think. Or we can if you want. So we have the target buffer then at the very end here, and we get a drawing context for it. And at this point now, we're just drawing like normal. We don't know in most of the code whether we're drawing to an off-screen buffer or to the main canvas directly. And so when we go down to, again, we're going to ignore the header, we're going to ignore damage. When we go down to see, all right, are we allowed to blit? Nope, that's still the header. Here we are. We're going to blit the last frame. Up here, we're going to pass this really ugly giant set of args. And we know we have our Blitz source, and it, wants to know a whole bunch of other things, like whether or not the Blitz source was scrolled and the target scroll position and, yada, yada, yada. But it's going to use all this data to figure out, okay, what do I blit from and what do I blit to and what rectangles do I need to blit over to draw it? And then this just gives us back a region list of everything we still have to fill in, like all the blanks that weren't blitted over. And then we're just going to go fill those blanks in. And so at this point, like the double buffering is handled just by like setting these variables up top. And then the very last thing that has to happen, now that we've done all that drawing, is, if I can find it right here, we go, okay, at the end, do we have a main context set? That was that thing we did at the very beginning. And if we do, we're going to basically clear that context and then draw the off-screen buffer to this. Technically, this shouldn't be required, because like this is a non-transparent buffer and it's the same size as this. But I have found on some beta versions of iOS, like you'd get these weird edge artifacts if you didn't do this. So again, this is another Safariism.
That is very interesting. And I just like, did you do a lot of trial and error? Did you like research the docs on like how Safari's rendering stuff, or a combination? Like, how did you find to do all this?
So with Safari, it's all trial and error. Like their documentation on their rendering errata doesn't exist. And by and large, this comes from, many, many moons of abusing drawing libraries and understanding how they work and what they're doing under the hood. You become familiar with, okay, I'm seeing this weird artifact. It's probably caused by like, I didn't align this line to a half pixel or whatever. There's all sorts of things you just kind of naturally begin to understand. And so, I think I wouldn't have been able to build this 5 years ago or 10 years ago. It took the culmination of 15 years of abusing drawing libraries to be able to get to a point where you can build a canvas-based data grid and have it perform well across multiple browsers, scaling, yada, 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 and add all these features and still have it work.
It's
an I swear,
inspiring
most
story.
of the code is not this bad.
It doesn't look so bad to me. Check out our channel. We wrote a TypeScript type that parses JSON, like just in the type system. So if you want to see 500 line TypeScript type, I got the hookup for you.
I'll tell you, one of the things that I struggle with so much is types, because so like we end up doing these things where we create these renderers for every cell type.
Mm-hmm.
And I want to like create these like, cell renderers where, hey, it's like T extends inner grid cell, and then you have like your cell type flowing through and everything. And this all works great until we get into like custom third-party cells where you want to flow through not just what T is, but like what, there's essentially another parameter here. And like, for the life of me, cannot make it happen. TypeScript has defeated me.
The way that a lot of libraries accomplish that is with ambient declarations that you have the user extend some interface on their side. So if they're adding something to, what was it? Inner cell, custom cell. Yeah. So like you have custom cell. And what you're saying is you want the user to be able to add something to this interface, right?
Well, what I want them to do is when they write a renderer to not have to cast that renderer so that like this T works correctly. And so like what happens right now, we actually use this same interface ourselves. So like here, they design like a dropdown cell is a custom cell with these props, right?
Mm-hmm.
And at the end, they're going to end up making this renderer here, down here. And they say, oh, it's a custom renderer of this type. And this is all nice. But then at some point, you get to this index.
So I'm not exactly sure. I can't say for sure, but what I've seen a lot is that when you as a library want to provide the user some way to extend a type, there's usually a way to do it using So the interfaces are globally open, so somebody can add something to an interface or change it. You can declare a global interface or something, and somebody can add something to it. So like, for example, if you wanted to make just some kind of like just expansion pack that like has extra expect functions or something, you can do that by providing your own extensions as a library. But that same process works with libraries and users, where you just say to the user, if you want to be able to, change this type on the go for whatever your use case is, like obviously the data has its own T, has its own value, then you can use like declaration merging or interface extension to do that. I'll take a look at it. Maybe you can send me some tips, or maybe somebody watching the video is interested in taking a look. It's definitely doable. I think.
Yeah, there's some place in here where we have to do this cast, and I just cannot get rid of it, and it's just driving me nuts. And I just need somebody who is like one of your viewers who really knows their TypeScript well to help me come figure this thing out.
The challenge is open.
And of course, I've buried it so deeply.
Yeah, that's okay. That's how most of these things are anyway. I don't think anyone would be deterred by that. I haven't done much rendering of like blitting things and putting rectangles together and stuff. But the little that I have done has reached problems with browser zoom levels and like subpixel rendering, creating a seam between what should be a solid block of things. I'm just curious if you've had any trouble with just specifically zoom levels and subpixel rendering and stuff. Even I've had trouble with it being different on Firefox than it is on Chrome and stuff, where it just, you see, you know what I'm saying? Like you see a line between colors.
The trick is twofold. One is to first understand how pixel alignment works on these grids. So if you want to draw like a one line pixel, as you may or may not know, you have to actually draw it at the half pixel boundary, right? Otherwise you end up with like a half strength 2 pixel line, because it kind of like splits that. It, like, you have to think of it as like an infinitely thin line going down whatever path you tell it to go down. So if you tell it to go down like the 1 line from 1 all the way down to like 1 comma 10 billion or whatever, right? What you're going to do is you're going to have that line directly between 2 pixels. And so when it tries to draw a 1 pixel line, it's going to draw a half pixel on this pixel and a half pixel on that pixel, and then average that. And so what you have to actually do is move it over a half pixel. So first, that's where a lot of people's seams come from, is they don't understand this half pixel alignment problem. And that generally comes when you're calling stroke. Now, when you're doing fill, the exact opposite is true. You actually want to align to those pixel borders. Now, if you're still getting it, which tends to happen now when you're using scaling, the trick is really straightforward, which is don't use partial scaling values. So I'll actually show you this. When we compute our scaling factor up here, we always call math that seal on the device pixel ratio. So we're always working with an integer scaling factor. Otherwise, anytime you're trying to butt 2 things up to each other, there's going to be blending that happens on those pixels, and you will get see-through.
Oh, so this is like effectively disregarding the user's zoom level, but only at fine percentage points.
Right. So what we're basically saying is, look, if your zoom level is 2.25, we'll just render at 3 and let it downsample, which will look pretty good. Which, by the way, is the exact trick that macOS uses. So when you set a zoom level that isn't an integer multiple, it just renders at the next largest integer multiple and then downsamples.
That is really interesting.
May or may not be where I figured out that trick.
So all of this stuff ties together to a product that looks pretty good. I mean, it's a beautiful looking grid, if I don't say so. What has that been like the performance and the math and pixel grids and all these things are one thing, but actually getting it to look good is a whole other problem. What's the styling story like then with all of this canvas stuff?
So you kind of do end up dealing with having to create your own theming. So we do support, theming. And the way you end up doing that is you just create a bunch of variables that go into a package. So, we call it a theme, and it just has, it's not that dissimilar from writing CSS. We actually do export all of these into, I don't know if I have it in here. we export all these into CSS variables so that they can be picked up by the overlay DOM elements. Because when we do something like this is now actually a real DOM input. It's an overlay. That's why it doesn't scroll with things.
Oh, nice.
And so this way, we don't want to recreate input elements like that. Like, I'm crazy. I'm not that crazy. So this way we can kind of share those theme values between these locations.
Gotcha. And then a user would just load up those CSS variables, or if they're using some like CSS and JS framework or something, they could just pass in the objects to the API. Yeah, there.
Exactly.
Okay.
So we define our themes up here.
And because you built it from scratch, there's no like, sometimes what happens in libraries, like I used to use Ant Design, like in the beginning of Ant Design days, before Material UI was worth a darn. It's great today, but back then it wasn't. And there was always this problem because Ant Design didn't support dark mode. So if you tried to restyle it to support dark mode, what you end up finding is all the places in their code where they accidentally hard coded like white or black. So do you code the app with only those style variables from the start?
Yeah, and in fact, it's easier to do that than with CSS. CSS has a lot of like implicit, cascading of values. And with the data grid, because I'm always having to, like, I have to set the fill style to something, otherwise nothing shows up. So I have to tell it, hey, I want you to draw with this color. It makes it very easy for me to know, okay, well, I'm drawing, so it's time to like, go fetch something from the theme. So it's not often, or it's very, very rare that I will have accidentally, left something so it's always styled incorrectly. Like it almost always will come from the theme just due to the nature of writing Canvas code.
I like that you've got the hot dog stand.
Yeah, well, that was the red and blue one you showed?
Yeah. My boss from the Xamarin days will be very happy to see this. Miguel Diacaza, who's of open source, royalty, big fan of the hot dog stand theme. So I built this for him.
That's wonderful. I mean, a downside of this seems like that you hit what I personally call the Helm charts problem. I came from is it still there? Yeah, but you can see my license plate. I came from the Kubernetes land, and Helm charts have this issue where if the person that made the Helm chart, it's, for those who don't know, it doesn't matter, but it's just and it's abstraction over a much larger config. But if the person who made that abstraction forgot to provide one value, then you're stuck. You have to like either fork it and make a new one. And so my question is, like, sometimes there may be apps that introduce things that's like styling constraints, like a gradient on a hover of a cell or something. I don't know. I'm just trying to think of something that you wouldn't necessarily think to do at first. So how do you handle those situations when somebody comes to you and says, hey, I need to be able to control this thing that there's not currently a knob exposed for?
So there are lots of controls that what we do is provide escape hatches. So if at any point in time you say, oh, I need to control the like rendering of the cells, I'm going to do this very inefficiently, so please forgive me. You can write draw cell. Thank you. So this is basically the no-op version of this command. You just give it a cell and then you call the internal render in here. But at any point in time, I can, get my context here. And then I can, fill rect here.
I see where you're going.
Yeah. Right. And I can start drawing under it.
I see. So by this mechanism, you could do lots of like custom things. You could do conditional formatting. You can do, highlighting certain like cells that have a search value that somewhere else was input, stuff like that. Yeah. Can all be done this way.
So this is like the lowest level escape hatch, but we go a lot further than that to make it easy. So that's like very low level. Like you can set individual themes just per row. So you can go to every row and say, I just want to override the theme for this. Right. And so here, what I'm doing is on these rows, I'm giving them a different border color so that this line here is a different color. And then I'm setting the background color different on these rows. Right. And so what you get is like this kind of like striping effect. Right. You can do the theme per column as well. right? So these have different text colors. I could set the background colors as well, right? And so just by being able to set the theme at the level of a row or a cell or a column, you get a lot more power out of your theme system than you would get otherwise. And it's only really when you want to go like totally nuts. So like we can go like the rapid updates event here. So this one is really about showing how fast we can process updates. You can see this counter ticking up. This is literally how many events it's processing. But
wow.
Each of these cells have custom themes based on the data inside of them. And you can see like
that's incredible.
It's fading in and out as stuff changes. It just, it's fairly expressive, but I didn't have to write any custom drawing code for this. I'm just changing the themes.
Wow. I used to work in a fintech company, and we had a dashboard that showed stock tickers updating, and there could be 1,000 stock ticker updates per second very easily, which is of course far more than even the draw rate. But we had to sort of handle all of this data being like piped into the app. And it was very difficult to do what you just showed on the screen, to get we tried to write it by hand. I mean, anything that we could do because of that DOM exchange, just going back and forth. It was, it's a real struggle to get that. So that's a very impressive demo you just showed.
1,000 per second ain't shit.
Nowadays, I mean, that was everybody was still writing Angular back then. I don't know.
Hundreds of thousands are definitely possible. Yeah. So here, this is like a more concrete example. So what I'm doing is I'm drawing a gradient, which is exactly what you spoke about doing, underneath the header, and then letting the header render. And then down here on each cell, I'm letting the cell render, and then I'm drawing this triangle over top. And again, these are just example demonstrations of what you could do. I can't imagine anybody wants a red triangle on every cell and cotton candy themed headers. But
I'm just so impressed by how much there is here. Where do you think this is going in the long term? I mean, it's been a few years and this feels very feature complete. What would you like to see from this next?
So what we're beginning to work on now is ecosystem. So what we have is a really solid drawing layer, an excellent set of cells. We support a ton of not just the built-in cells where it's kind of your basics for what you need for drawing a grid, but also we have all these third-party cells which show stars and tags and profiles and ranges and whatever else.
So for example, like there's a slider in is it range? Is it? So if I have or no, it's just a bar. It is a slider. Okay. So if I have a slider in my UI library, if I use MUI or whatever, Blueprint.js, and I want to use that same slider in the cell, it's very easy to do that, is it?
It's relatively easy to take the existing renderer, grab everything you want from it, and just replace the editor. We call this overlay thing the editor. And you can just replace that editor with whatever you want it to be. And it's like one React component you have to replace.
Cool.
And so that's very straightforward to do. But yeah, so we have all this stuff. So what's really next is beginning to work on data source packages. So, we have undo redo support coming. So this is emulating a server. So every data fetch takes 300 milliseconds. And you can see you generally don't see it because it knows about paging and it tries to keep ahead of you. But because it's 300 milliseconds, you can outpace it. So, you can eventually get to a point where you don't see it anymore. And so we're beginning to work on this kind of larger set of hooks and controls and ways to talk to data sources. So you don't have to do it yourself. You're able to leverage what we're already providing for you.
Yeah, that is the cutting edge, isn't it? I mean, server-side everything is way more common these days, I think, as time goes on. So it's cool to see you keeping up with that. 10 million cells. Okay.
Yeah. Oh, yeah. There's a fun one in here, which is this one. This is 100 million rows. And you can scroll to the very bottom.
Oh my goodness.
What's interesting about doing 100 million rows is this is now taller in terms of pixels than what a browser actually supports by a wide margin. So browsers have a maximum div height. And no matter what you do, you can't make a scrollable region scroll more than that. So what we have to do is reinterpret what each of the scroll steps actually means. And you might think, well, that would make it so that when I scroll my wheel, like it would feel like you're scrolling way too fast. So we also have the concept of a local scroll and a global scroll. So when you're scrolling via this thing, it's just direct recomputation. But when we use the wheel, it's all just beautiful and, feels very natural and native. And that lets you get to any point in the scroll view you want, and it just works.
Glorious. That's just amazing. Yeah.
Each of these are 32 pixels. If you're scrolled all the way at the bottom, the top of the grid is pretty much to the moon.
Oh man. I was going to say, I think just with some of this is super impressive because some of the data libraries that I've seen that are using the DOM, once they get above, tens of thousands, they start dropping out. Not when you're talking millions, that's next level, especially to get to this.
It can be really challenging to figure out how to scale beyond tens of thousands. And I'll tell you, do I think anybody needs 100 million rows? In general, no. But our use case did come from needing to show 25,000 rows. And even at that scale, most of the DOM solutions were not able to keep up. They either would tell you have to move to paging, which wasn't the user experience we wanted, or the performance was just so bad that you didn't want to live with it.
Yeah, I mean, it seems like this has a fairly linear performance gradient. It seems like as you add more, it does the same set of steps to calculate the same things, and you don't get a tax on how many things are in the table.
There's only two steps in the performance gradient. The first is when you cross this 33 million pixels in height. That requires us to do extra math at every scroll. It's not that bad though. And then the other is if you enable, where is it?
Uneven rows. I was wondering about that actually.
Yeah, if you enable this also requires us to compute the row heights before that point. Now we do keep it cached so we can continue, right? We don't recompute from the top every time.
I got you. Yeah, I mean, for those watching, this is this uneven rows thing among data grids is a kind of notorious demo because this is something that is very tricky to do with certain architectures. And that means if you have an architecture that multiplies the row height by the number of rows to get some kind of height or position or something, all of a sudden, if there's an uneven number of rows, you can't do that anymore. You gotta just crudge your way through every single row. So it's a cool demo always to see uneven rows in a data grid.
Yeah. I mean, what's funny is this is probably slightly easier than that. Just underlining text. Because Canvas doesn't have the underline ability.
Oh, yeah.
So, and if you look really closely, you might be able to tell that underline actually breaks for the descenders. Which I don't think you'll find. Yeah, I don't think you will find any other Canvas libraries doing this right now. I think I'm the first one that actually does that. And the mechanism of doing that, you don't even want to know. But let's just say it involves rendering that same text string 5 times.
Wow.
I love it though. I'm a big fan. Oh, and then so there's an overlap of those 5 times, and okay, I kind of understand.
Yeah. What I'm doing is rendering the text at 1 pixel offsets, left to right, so that it blots out the underline in the right areas. Mm-hmm. Because otherwise, you don't have the metrics required to do it. So yeah, that thing is just hilariously complicated to make work.
So we've been starting to ask every interview that we do, every showcase, a question for the next showcase. And then also I'm going to ask you now, so you can think on that for a second. The last showcase we had was with the people from Apollo Client, and they asked, what's a conference you've never visited that you would like to?
I know that this is going to probably be a popular answer, but I've never been to GDC. I was supposed to go the year COVID happened, and then haven't had the opportunity to go ever since. And as you can tell, I'm very interested in rendering, and that doesn't stop at 2D. I'm also in love with 3D rendering. And like,
Yeah.
there was this moment where somebody, as a young engineer, somebody explained the depth buffer to me as like, how do you render things so that all the triangles end up in the right order in 3D and not have them like, things in the back overlapping things in the front. And like,
yeah,
I couldn't figure out how you would do that without like sorting all of these triangles. And somebody explained the depth buffer concept to me. And like, that was the first moment I was like, oh man, that's just a beautiful algorithm and just a beautiful way of thinking about a problem. And it just kind of made me start to fall in love with this concept of drawing.
I love that answer because I think it rings true to a lot of people. GDC is definitely some of my favorite talks ever were GDC talks. I haven't been in either myself, so maybe I'll see you there next year.
Happy to be there.
And then one more administrative question before I ask you your question. So keep thinking in the background. There's a survey of JavaScript, a survey of CSS and stuff where there's lots of interesting questions asked about familiarity of certain features. And I think library authors are very interested in those surveys because they kind of inform what the people out there are wondering and also what they know. And we're kind of, Michigan TypeScript is sort of in league with people who are working on making a survey of TypeScript, not the same as the survey of JavaScript, but actually just focused on TypeScript's type system and features that library authors need. So it'd be like kind of a more advanced kind of look at things. And I'm curious if you have a question that you ask yourself sometimes about your users, like, are they, maybe there's some TypeScript feature you're wondering if they're comfortable using, or maybe there's, something like that. So I would just want to know, is there anything that you think should be added to the survey of TypeScript that or something that comes out in your mind a lot while working on the Glide Data Grid?
So there is this, I don't know how to put this into a question exactly, but there's this thing that as a library author, you do a lot. You use optional parameters heavily because you want the convenience for your user. And what they probably don't realize is that, especially in like super tight, hot loops, this really hurts performance because you de-optimize the JIT all the time if you're getting different shapes coming through. And a debate I constantly have with myself is, should I enforce? Now, obviously, this is not a place, but when you're like generating the cells in the data grid, should I enforce that there are no optional things? You have to fill out all of the objects or all of the properties in the object. And by doing that, I know I get a decent performance uplift, but like, it's kind of a pain for the users. And, the copy is way more expensive. If I like go ahead and like preemptively copy it to fill out everything, that adds way more cost than what I save.
Sure.
So yeah, I don't know how to phrase that into a question exactly, but like, I'd be very curious what people's take on like libraries doing that kind of thing would be.
That's great. No, that's a great question. Like what the desirable knobs to turn are for an API of a tight loop. That's a great question. And, this exact topic you touched on is one that I care about too. There's a TypeScript option, tsconfig option called exact optional property types that sort of dances in the domain of this question of like the difference between something being there, but the value possibly being undefined, or just not being there at all, which in some contexts in TypeScript is the same, but in others, like object.keys, is very different. So yeah. Some people care, some people don't care. It's hard to know what a library needs. So that's great. All right. Did you think of a question you'd like me to? It can be any kind of question. So it can be what their favorite tikka masala recipe is. It doesn't have to be programming related. But what should I ask the next showcase?
I think I would love to know what the absolute craziest thing they've ever made with an HTML canvas is. I love hearing people's stories. Every time I've asked this of like interview candidates or whatever, I get really weird responses. It's been a lot of fun for me, so I'd love to hear what they think.
Wonderful. I'll tee it up. The next group we have is Mark from Redux and Anderist, the TypeScript guru, and he's going to be showing how he uses replay to debug the TypeScript compiler. So
I love the replay guys.
Oh, you do? Okay. Well, Stay tuned. It's the very one we're recording tomorrow, so it's going to be up very soon on the channel.
Oh, excellent.
So that's great. Good to hear that. So did we miss anything? Is there any major machinery that you wanted to touch on that we didn't get to?
I think the only thing that I would probably share with people is a lot of people thought that this was like a very silly thing to do. And like, I kind of have to agree with them to a certain extent. If you don't have a very specific set of needs, building your own data grid in Canvas is borderline insanity. But the benefit of having done it is I've learned a lot more about how browsers work, about how the DOM works, about how front ends work. I've learned a lot more about how JavaScript itself works under the hood, just by having to push it this far and this hard. And I would not advise most people go out and build their own data grid with a canvas, but I would strongly advise that you consider leveraging the pain that I've put into it. But if you ever have your opportunity to find your own canvas data grid style problem, and it makes sense for you to engage in it, it can be a huge learning opportunity. You know, I've become a better engineer because of this project.
Very inspiring words. Yeah, I love that. It's sometimes it's cool to just try doing strange things and or impossible tasks. Sometimes are more possible than you think. All right. Well, I think that's all we got for today. Thank you, Jason, for coming on, Ryan, and we'll hear more from you. If you have any questions, guys, comment down below, and we'll be hearing from you all soon.